They were solving systems of linear inequalities, and we're going to do that by graphing. So, number one, we've got a couple different inequalities, one here and one here. We're going to graph them so that we can find their solution. So, for this first inequality, if I put in a 0 for x, I get 7y, and I'm just going to use equals for right now, negative 21, and I divide and I get y equals negative 3. So there's my origin, 1, 2, 3 down. There's my y-intercept. Okay, now if I do the same to get x, I would divide negative 21 by negative 4, and that's not a whole number. So I don't want to do that. I don't want to deal with fractions. But remember that the slope from standard form is the opposite of a over b. So the slope is the opposite of negative 4 over 7. So the slope is 4/7. So from here I can go up 4 and write 7. And this is an inequality. It is underlined, so I know it's going to be a solid line. The other thing we have to do when graphing inequalities is shade. So if I put in 0, 0, testing the origin, I get 0 plus 0 is greater than or equal to negative 21. And 0 really is greater than or equal to negative 21, so that's a true statement. This line right here shades toward the origin. I'm just going to put in those dots for now to tell me I'm shading this way. Okay, then we're going to do the same for this equation right here. If I put in a 0 for x, I get 7y is 28. And divide 28 by 7, I get y is 4. So my y-intercept, 1, 2, 3, 4. If I put in a 0 here for y, I get 3x is 28, and 3 does not go into 28 evenly, so again, I'm going to use the slope. The opposite of a is negative 3, and b is 7. So the slope is negative 3 over 7. Down 3, right 7. And again, this one is solid because it is an underlined inequality symbol. Okay, so here's where they intersect. So if it's just lines, then that point right there is my solution. But these are inequalities, so I need to shade again. Put in 0 and 0. I get 0 is less than or equal to 28, and that is true. So this one also wants me to shade toward the origin, and the area that got shaded both times was in here. Okay, so everything in this region that would then extend infinitely would satisfy these two inequalities. Okay, on number 2, I have 3 inequalities. X is less than or equal to 3. So I'm going to graph the line x equals 3. 1, 2, 3. That's a vertical line right there. X equals 3. All of these are underlined, so they're all going to be solid lines. If I plug in the origin, 0 is less than or equal to 3. That is true, so I shade this one toward the origin. Y is less than or equal to 5, so I graph y as 5. Zero is less than or equal to 5. That is true, so this one also shades toward the origin. So far, it's this region here that's gotten shaded both times. Then x plus y is 1. Okay, so this one might be simple just to put into slope-intercept form. I'll move that x over. Y is greater than or equal to negative x plus 1. So I've got a y-intercept of 1 and a slope of negative 1, so down 1 and right 1. And I'm going to do that as many times as I can fit on the graph, and up and left keeps that same pattern going. And here, if I put in 0 plus 0 is greater than or equal to 1, That is false. This one wants to shade away from the origin. So the origin's over here. So I'm going to shade this direction. And I can see that what got shaded all 3 times is inside this region. So it's anything on the boundaries and inside of that region that satisfies all 3 inequalities. Okay, now we're going to take that one step further. So first we're going to graph and shade. So we've got x is 0. Okay, so that's right here on the x-axis. Okay, now I can't check the origin because the origin is on the line. So how about if I check the point 1, 1? So the x value is 1. 1 is greater than or equal to 0. That is true. This wants me to shade toward that point that I just tested, 1, 1. So I'm shading to the right. Next, y is greater than or equal to 0. So that's right here on the x-axis. And I think I called this one the x-axis a minute ago. So x equals 0 is the y-axis. Y equals 0 is the x-axis. And since, again, we go through the origin, I'm going to test the point 1, 1. So I get 1 for y is greater than or equal to 0. That is true. So this one also wants to shade up. So this far, I've shaded everything over here both times. Okay, next, y is greater than or equal to x minus 4. So this one has a y-intercept of -4, which is going to be kind of tough to graph. So instead, let's check the x-intercept. What if I put in a 0 for y? And I'm just going to use equals for now. And I move that to the other side. The x-intercept is 4. Okay, so I put in a 0 for y so I can find the x-intercept, and I get x is 4. So there's my x-intercept. My slope here is 1, so it's up 1 over 1. Okay, now if I put in 0, 0, I get 0 is greater than or equal to -4, and that is true. This one wants to shade toward the origin. So now I've shaded this region all 3 times, and I've got a 4th point. Okay, so for this 4th point, if I put in a 0 for x, I get 6y is 54, and divide. Okay, so 6 goes into 54 9 times. So y is 9. And 7 does not go into 54 evenly, so I'm going to use the slope. That is the opposite of A, opposite of 7 over B. So -7 over 6. So down 7 over 6. And when I shade, I get 0 plus 0 is less than or equal to 54, and that is true. This one shades toward the origin, and I have shaded this area all 4 times. So that region is what satisfies all 4 inequalities. Okay? Now, it says, name the coordinates of the vertices of the polygonal convex set. So that means just name the corners of this polygon. So I've got a point at 0, 0, a point at 4, 0, then a point at 6, 2, and a point at 0, 9. So those are the coordinates of the polygonal convex set. Okay, let's try another one. X is greater than or equal to 0, so that is the y-axis. X is 0. Y plus 2 is greater than or equal to 0, so that's y is greater than or equal to, and I move that 2 over, -2. So y is -2. I should have checked where I'm shading, so before I go any further, 0 is greater than or equal to 0. I don't really want to use 0 for that one because the origin is on that line. So how about 1, 1? 1 is greater than or equal to 0? True. So I'm shading toward the point 1, 1. This one I can use the origin because it's not on this line. So 0 plus 2 is greater than or equal to 0. 2 is greater than or equal to 0 is true, so I'm shading this way. So far I've shaded this region both times. And last, 5x plus 6y is less than or equal to 18. So if I put in a 0 for x, I get 6y is 18. So y is 3. So there's my y-intercept. 5 does not go into 18, so I'll check the slope. Opposite of a is -5. b is 6. So -5 over 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So there's my third line. If I put in 0, 0, I get 0 plus 0 is less than or equal to 18. That is true. It shades this way toward the origin, and all 3 times this region got shaded. Okay, so I've got a coordinate right here, here, and here. So I have one at 0, -2. Then at 1, 2, 3, 4, 5, 6, -2. And at 0, 3. All right, this one takes it just a little bit further. So we're finding a maximum and minimum for this function based on the coordinates of the vertices of the polygonal set, the convex polygonal set, formed by these 3 lines. Okay? So, for the first line, if I put in a 0 for x, I get -2y is 0. And when I divide, I get y is 0. So my y-intercept is 0. Okay? Now if I did that for x, I would get the same thing. So my x-intercept is 0. That doesn't really give me a line, so I need to do the slope. The opposite of a is -3. b is -2. So that's +3 over 2. So up 3 over 2. So there's my first line. 0 minus 0 is greater than or equal to 0. I don't want to do that because the origin is on it. How about this time if I do 1, 0? So I'm going to do the point 1, 0. So 3 times 1 minus 2 times 0, that's 3 minus 0. 3 is greater than or equal to 0. That is true, so I'm shading toward the point that I just tested. Y is greater than or equal to 0. That would be on the x-axis. And if we really think about it, y is greater than or equal to 0. Just greater than means it's got to be above that line. So we're going this way, shading up. So far I've shaded this area both times. Then for this last line, if I put in a 0 for x, I get 2y is 12, or is 24. So y is 12. I got a little ahead of myself there. Let's go back and get rid of that. So 2y is 24, so y is 12. Is that going to fit on here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, I guess I could kind of go up a little further, but let's just check the x and see if that works better. So I've got 3x, and put in a 0 for y. So I get x is 8. That'll work nicely. So we'll go right 8. And from there, let's just use the slope. So the slope is the opposite of A, so negative 3 over B, which is 2. Negative 3 over 2, so that's down and right, or we can go up and left. So there's my last line. Okay, and when I test the origin, I get 0 plus 0 is less than or equal to 24. That is true, so shade toward the origin, and it's inside this triangle that got shaded all 3 times. Okay, so I am going to evaluate this function for all 3 coordinates. Okay, so I'm going to make a table. X's and Y's for the function, which is 7y minus 3x. Okay, so first I've got the coordinates here, 0, 0. So that's 7 times 0 minus 3 times 0. That is 0 minus 0, which is 0. Okay, then I've got 8, 0. Okay, so I've got 7 times 0 minus 3 times 8, which is negative 24. And then my last coordinate, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I've got 4, 6. So that's 7 times 6, which is 42, minus 3 times 4, which is 12, and that is 30. So we are asked for a maximum and a minimum value for this function given those coordinates. So for this one, my maximum is the highest output, and that is 30, and the minimum is the lowest output, which is negative 24. My last one here, I've got a y-intercept of 8 and a slope of negative 1. So down and right. And if I plug in zeros, I get 0 is less than or equal to 8. That is true. I'm shading this direction. Next line, if I put in a 0 for x, I get negative 3y is negative 3. So y is 1. So I've got a y-intercept of 1. 4 doesn't go into negative 3, so I'll use the slope. Opposite of a is negative 4. b is negative 3. So it's positive 4/3. So there's my second line. If I plug in the origin, 0 minus 0 is greater than or equal to negative 3. That is true. So I'm shading toward the origin. So now I've shaded this region both times. And my last line, if I put in 0 for x, I get 8y is 8. So y is 1. So I'm right there, and a y-intercept of 1. If I put in a 0 for y, I get x is 8. So my x-intercept is 8. So there's my last line. And when I put in the origin, I get 0 plus 0 is greater than or equal to 8. That is false. The origin is up here, so I shade away from that. And what got shaded all 3 times is that triangle. So now we need to evaluate our function. Okay, so I've got coordinates here of 0, 1. Okay, so that's 4 times 0 minus 5 times 1. Then I've got coordinates here of 8, 0. So that's 4 times 8. Okay, so 4 times 8 is 32. Minus 5 times 0. So I get an output of 32 there. And my last coordinates are at 3, 5. So when I plug in a 3 here, 4 times 3 is 12, minus 5 times 5 is 25, and I get negative 13. So the maximum is the highest output, which was 32. The minimum is the lowest output, which was negative 13. We're going to end this lesson with some practice of matrix and calculator skills. So in order to complete each of these problems, I'm going to enter these 4 matrices into the calculator. So I'll do second matrix, and I will go to edit, and I'll edit matrix 1. So I'll edit that to a 3 by 2 matrix. And start entering my elements, 4, 2, 6, 7, negative 2, negative 4. Okay, and then I'll go back to matrix, second matrix, edit matrix 2, and I'll do this for all 4 matrices. Now that my matrices are all entered, I will hit second quit, and I'm out of the matrices, so now I'm going to put in matrix A times matrix B, so that's second matrix A times second matrix B, and it gives me 22, 6, 53, 37, negative 26, negative 24. Okay, then I've got matrix B times matrix A, second matrix B, second matrix A, and the dimensions don't work out to multiply those, so this one is not possible. Then it's matrix C plus matrix D, second matrix C, better clear that out first, second matrix C plus second matrix D, 7, 5.3, negative 5, negative 4, 10.4, 7.4. And then parentheses, and 3 times matrix C minus matrix D, close parentheses, times matrix A, negative 13.8, negative 7.1, 0.4, negative 31.2. Okay, and then we are going to solve this system using matrices. So we'll go to matrix, we'll edit matrix 1, and we'll make this a 3 by 3 matrix. Okay, so I have 10, 3, 1. And then I don't have an x in this second equation, so 0, 32, 6. And then 128, negative 20, and I do not have a z, so that would be a 0. And then I will edit matrix 2, and matrix 2 is going to be a 3 by 1 matrix. 2, 29 fourths, 43 fourths. Okay, so I will hit second and quit, and I'm back to my home screen. So what I need to do is multiply the inverse of matrix A, so that's matrix A inverse times matrix B, and I get these as my
X, Y, and Z. So I'm going to hit math, enter, enter to get fractions. So I have 3 30-seconds. So X is 3 30-seconds. Y is 1/16. And Z is 7/8.